good evening, everyone, or good afternoon, depending on where you are. Today, we are hosting our very first session on the new series, What is Artificial Intelligence? From the statistics of the club, I know that we have a huge majority of AI students, the bachelors of AI at our university of Pavia. And so I believe this is one topic that's of huge interest to the majority of this club. And so for that reason, we decided to launch our What is AI series. So for our first session, we wanted to talk about an interesting topic, which is natural language processing, which is very interesting for its usage all over the world and how we can use it in so many topics. So to start with, we decided to invite Nima Kamali, who is an intern at the Turkish Ministry of Justice, and he was also the GDSC lead of the University of Bilkent, or Bilkent University, last year. And he has been working with machine learning and AI and natural language processing specifically, and BERT for the last few months. So he is an expert in this topic, and he has been working with it. He's been tested along with like many projects, and two specifically very successful projects on the topic itself. So we are very honored to have him today and to welcome today. Thank you, Nima, for joining us, and you can go ahead and take on the lead.
No, thank you, Ubay. So as Ubay mentioned, I actually work in the Directorate General Information Technologies of Ministry of Justice in the Republic of Turkey. And so the models that I'm actually going to show to you for the examples are using Turkish language, but don't worry, even I'm not that good in Turkish. I'm not Turkish myself. Yeah, you don't have to speak a certain language to actually work on natural language processing. So let's just jump into the presentation. I'm going to share my screen right now. Just let me know if you can see my screen. Okay, let's just jump into it. So first of all, I'm going to explain what is AI and machine learning, so that you actually are going to have a clearer mindset of how NLP fits into all of this, and also what is NLP at the end of this first part, of course. And then we are going to move on to how can we actually make use of machine learning and NLP in general, while collecting our data and creating the model, and of course the training phase. Then I really hope we have the time to cover BERT, which is Google's state-of-the-art model for natural language processing. But in case we can't cover it in this event, we can actually just have a Q&A at the end. Then we can maybe have an event next week to continue with BERT. So let's just our fingers crossed to continue for now. So what is artificial intelligence? I mean, you might actually be surprised by how simple artificial intelligence can be. So anything that is, very simply put, smart is actually also artificially intelligent. What do I mean by that? For example, in your house, you probably have an AC that is actually capable of checking the room temperature. So let's say, for example, whenever the temperature of your house drops to lower than 26, actually goes above 26, let's say it turns on and brings the temperature lower under 26, then turns off again. Every time the temperature goes up, it turns on. Every time, and when the temperature goes down again, it just turns off. So that AC is actually artificially intelligent because it's a program that is always running, and it's smart. It knows what to do when something happens. So that makes artificial intelligence an umbrella term. It's a really big topic. So what we normally think of as AI is actually mostly machine learning. What is machine learning? I mean, from my experience, if I wanted to put it very simply, it would be it's how a machine can find the similarities between things, between our data. And deep learning is actually a lower level inside machine learning, which I hope we can get into. And what do I mean by finding similarities? Let's say, for example, a machine learning algorithm, a model, can actually, for example, distinguish a picture of a dog. It knows that the picture is actually it includes a dog inside. There's a dog inside the picture, for example. It's just a very simple image processing model. So it's just it's been given data, even given pictures of the dogs before. It's been fed pictures of them. So it actually starts to find similarities in the pictures. It starts to understand what is being shared in between all of those pictures, oh, there's a dog there. So it's going to always, when you give it a picture, it's going to be like, there is a dog in this picture, there's no dog in this picture. It's very simple if you think about it this way. It's just finding similarities between things. However, NLP, even though it can be a machine learning tool, and it most of the time is, it doesn't have to necessarily be one. So it's because the process, the natural language processing, the process of data, does not always be, is not always done in a smart way. Like it can just begin and finish, just get a simple program. However, there is this subtopic inside NLP, which is NLU, natural language understanding, which is always machine learning. We can continue with here. So NLP, yes, it's a subfield of AI. And what is the point of natural language processing? So it's just that a machine, a computer, can understand what does the natural language we daily speak means. So it tries to understand the meaning of the language we're using right now. For example, English is a natural language. We're trying to teach the model how to understand English language. And you would be like, so what's the point of this? Why would we even do NLP? What are we going to get from it? So it's actually being used many places that you might not be aware of. The most the most used, let's say the best use of machine learning in NLP that you have probably seen is in banking applications where there is a chatbot, or maybe maybe when you order food and you want to see the status of your order, there's a bot, you can just text it like, okay, where's my food, and the bot is going to answer you, it's on the way, things like this. The chatbot is probably the funnest one, but it actually has many uses, especially when it comes to corporations that are dealing with very large data, sometimes even big data. Processing natural language can actually help digitalize many things, and it can help firms actually move on from their legendary systems into modern stuff. And I can actually show you an example from a very simple model I made with BERT, which is, I think you can see this tab, right? You can see it, I assume. No one is saying anything, so okay.
Yeah, it's working well, don't worry.
Okay. So a very simple model I made is actually for blocking spam messages. And you can actually just see this code on Hugging Face. Maybe I can share the code for you if you're actually interested. It's very simple to do a model like this, which is for binary text classification. What does it do? What it does is to separate the text that we give it into two different classes. Either the text that I put here is a spam message, or it's not a spam message, it's a normal message. So the model that you're seeing here, as I said before, it's been trained on Turkish datasets, so I have to write everything in Turkish. For example, if I tell the model, hello, how are you? When I analyze it, unfortunately it takes a bit of time because it has to load the model every time. It's not a very clean code for this model. It processes the text and it says, this is a normal text. So I said, hello, how are you? But when I say like, buy right now, and like there is 500 Turkish liras discount, then when I say something like this, it should predict it as a spam class text. I believe it's loading right now, yeah. Let's wait. Yeah, the spam class, as you see. This is a very simple use of it, which you probably have in your phones already, or maybe your phone already blocks them. Or whenever you receive a message from a specific number, your phone is going to give you an alert. This is probably spam. Do you want to block it? Maybe you also have this in Gmail. It happens a lot that Gmail tells you about the spam messages, or it goes to your spam directory inside your mailbox, which is very common use of natural language processing. And then we can actually see the other model later on in the presentation. So I hope you have an idea of what are the uses of NLP. NLP is probably the most used version of machine learning right now. Really close second would be image processing, which probably is more fun than doing NLP, but it's a very important task. So what are the steps in doing natural language processing? First of all, you should actually decide all of your what you plan to do with the NLP. Do you want to create a chatbot? Maybe you want to do question and answer? Maybe you want to make a bot that can read the text, and then when you ask it questions about the text, it can find the answers inside that text for you. Actually, one other use that currently exists right now is bots that create questions that are used sometimes for making exams for certain courses. These bots just read the book and then start creating questions from the book, which is really interesting one, which is actually not good for us as students, but it's very interesting use of natural language processing. So to create a model that does natural language processing, we first have to prepare our data, which is the text data, of course. We then have to tokenize it. Tokenization is actually a step that consists of many other steps inside itself. It's probably the most important one. It's when you get the data and you turn it into something that the computer can understand. It's the part where natural language turns into machine language. After we do tokenization and our data is ready, we create our model and train it. And then we can evaluate the model at the end to actually see how successfully it's working, yeah. So in NLP, you probably, actually machine learning generally, you have probably heard of the word supervised, unsupervised, semi-supervised learnings. And what do they mean? If I say it very simply again, so supervised learning is when we define for the machine learning model how to find these relationships between the data, how to find the similarities between them. We have actually told, for example, this model that look for ears in this picture, look for a mouth in this picture, look for the eyes, and it's gonna be like, okay, so if I see these things inside another picture, it's probably a dog, and it's gonna keep being trained on that one. In unsupervised models, it's a bit different. It's so the model on its own is going to find the connections. We don't define for it how to find the similarities. Maybe it just goes pixel by pixel, then it says when I see these pixels inside the screen, then it probably means it's a dog. It's going to be looking for connections that maybe we humans never even think of. It's just going to go for algorithms on the back end that we're not going to see. And an example for this would be maybe actually the one project that I did in my workplace was to create a grammar correction natural language processing model. And what I did was to use BERT model from Google, but I did not teach it any of the grammar laws in Turkish. I just gave it the text where the grammar was wrong from Twitter. And I also gave it the Twitter text where the grammar was corrected. And on its own, it found so many grammar rules that do exist in the language, but I did not teach it any of them. It just found it on its own. For example, there are certain vowels in Turkish that you cannot repeat inside the same word, or maybe there are certain letters that you cannot repeat inside the same word. And it actually learned it on its own that where this law applies or where it doesn't, which is really interesting. Like maybe 10,000 tweets, it managed to figure out so many Turkish grammar rules. That's why unsupervised learning is a very, very big thing now. The transformers models, especially recently, have been announced. Like they were revealed in maybe 2019, 2020, and they have changed the game a lot. That's the nice thing about machine learning. It's always changing. It's always improving. And at the end, semi-supervised learning is when you have a combination of these two. So you can actually define, okay, there are these differences. This is how you can find them. And at the same time, you can look for other differences on your own, which is a very good method. Most of the time, I actually did unsupervised because maybe my text was mostly very simple. I did not have to define things. I didn't really have the case to do semi-supervised learning, and maybe you don't have to either. It really depends. Like you have to actually define your steps based on what goal you are trying to approach. So these are the two models. I actually showed you the first one that I managed to actually share them publicly. Another model that I had was for Multiclassics classification, which is trained on the TC32 Turkish dataset. It's one of the biggest datasets that you can find in Turkish, which is actually customer customer reviews on products that they bought from internet. And there's 32 different categories that these products belong to. So let's just go down here. As you see, the accuracy of the model is here. As I mentioned, the evaluation part. You can actually have a validation data set so that you can check the accuracy, but this part is not very important. If you have any question about this, you can actually ask me at the end of the meeting. Don't worry about it much right now. So what is the model itself doing? So for example, here I put a text about there's this mother that is saying, oh, I actually buy like this product for my children all the time, and the price has increased a lot. It went from 135 Turkish liras to 180, and she is not happy about this. And what the model is actually giving us back is that this text is related to mother-child relationships. It's related to mother-child products. So I can actually just change this. Maybe I don't have Turkish keyboard on my laptop, but it doesn't matter if your model is semi-supervised. You can actually find the connections. I'm just going to say like, it's like this product arrived really fast. Let's try this.
If you want, I can text it in the chat for you. I have it on my keyboard.
Oh, it's fine. No, it's not a problem. It works in the markets. Yeah. So when I searched it arrived really fast. The model told me cargo transportation related text. You see, it actually is working pretty well. Maybe we can try other text if you want to, but let's not spend much time on this. So there's 32 different categories, and this thing would really help when it comes to classifying documents. Like if you have like many documents and you don't have the time to take a look at each of them and put them in different categories yourself, a natural language processing model like this can help a lot, especially imagine like how it would help in governments when you're dealing with many what do you call it, people's documents, especially that you can't really share them with many people, but you can just share it with an AI because no one is seeing the data. It's really good. So machine learning pipeline, this is how you have to, the steps you have to take towards your model training. Data collection. Data is really important in machine learning. It doesn't matter how good your model is. If your data is not good enough, you're going to have problems in the future. So let me just give you an example. So I talked about image classification. Again, it's very similar. Machine learning is generally very similar between different tasks. I'm just giving an example from image classification because I think it's easier to understand. So let's say we have this model that is going to recognize the picture of dogs, and we show it to Doberman. And we keep showing it pictures of different Dobermans, and it's going to you're going to think that all dogs should look like this dog. But when we show it a picture of a terrier dog, it's going to be like, this is not a dog. So that's a problem in our data. Even though it is a dog, our model did not know it because our data was biased. Our data was very limited. It was not diverse enough. So in the data collection phase, in the beginning, spend as much time as you can to gather the best data for your model, the most diverse, the most number of data. The second step is actually data processing. So before I move to it, I'm just going to mention, even if you can't gather many numbers of data, if your data is very clean and it's easy for the model to see the differences and similarities between them, you won't have a problem. That's why data processing step is very important. After you gather the data, we come into cleaning the data. The process of data is very important because you don't want to get your model confused on many stuff. And text representation is when you turn the data into a numerical value so that the machine can understand it. That's where the natural language turns into machine language. At the end, we can feed this data into our model and start the model training part. So for us, working on Turkish language, we actually went with so many different data sets. We looked at all of them, especially because we hadn't decided what our model should be yet. We were looking for the best data. That's the first step you have to take. Even if you don't know what you're going to do exactly, you have to have good data. So there is this data set, for example, Oscar. Oscar library is really good because it keeps billions of words in different languages. So you can train your model on those words. For example, in Turkish, it holds around 6 billion words and 75 gigabytes of data. So when it comes to training your model, you're going to cover so many words that your model is not going to be confused about the words that it doesn't know. And again, it's very important to be as diverse as possible. I believe for Italian, there's actually around 300 gigabytes of words also. Italian is the third biggest language when it comes to machine learning data sets. So if you guys are interested in that, you should have a fun time with Oscar's library. Then in the data processing part, we have the data cleaning, as I mentioned. There are 3 different steps that you can take. Before I continue, I want to mention this, that I'm talking generally right now. I'm not talking about transformers models, which are like the current generation of the natural language processing. And these tips that you see here, you don't really have to take them in the more modern tools. So don't worry about it if you don't understand it much. I'm not going to waste much time on this. The first part is softmax, which we just do by just saying like dot softmax. You just do a very simple function that does it for you. What does softmax mean? What softmax does is that it creates more difference between the data that you currently have. For example, if your data is, let's say, 1, 2, and 5, it's going to separate them with, for example, the first number is going to be 1, the 2 is going to turn into a 5, the 5 is going to turn into a 10. They're going to be more distant from each other, so that it's easier for the machine learning model to understand the differences in the data. It's a very simple mathematics. But it does help a lot when it comes to statistics and machine learning. And then there's stemming and lemmatization. Again, this step is actually better if you don't do it when it comes to the current gen models, but I'm going to explain it right now. And there is also stop words cleaning. I believe we have a slides about the stemming and lemmatization, so I'm just going to explain the stop words cleaning first. So if you have a stop words in your sentences, what do stop words mean? Like, for example, the punctuations, the exclamation point, and maybe you also have the word the word is, the word by, the words that keep repeating in your sentences. It's better to remove them when it comes to older models because it's going to make your model biased towards those words because they repeat so much in our natural language when we keep talking. They can just repeat so many times that it's going to make your data biased. So it's better to just remove them from the data and just process text without the stop words. In English, it's very simple to remove them. You just get a library in Python, for example, that just holds the data set and just remove them from your text. In the language, actually, doesn't matter. It's very simple to get rid of stop words. I'm not sure about other languages. In Turkish, it's a bit difficult because the words can actually have multiple meanings. And when it comes to removing them without machine learning, as this step does in stop words removal, you're going to have a problem. Okay, let's move on to stemming. What is stemming? Stemming is to get the root of a word. For example, if you have the word clean, it's going to turn into clean. If you have the word eat, it's going to turn into eat. You are getting the root of each word so that if your model does not understand many words, it helps it understand the meaning behind the word that it doesn't know. Again, we don't need this for modern tools. I keep saying it, I'm sorry, but it's just a fact. And again, if you want to do this step, it's very easy. For example, for Turkish, we have the Turkish stemmer and Zeyrek, we use a lot, that just has this library that you just give it a word and it gives you different versions of the word. When it's being used like as a verb, when it's being used as a subject, they can just keep changing forms and it just shows you the form that you want. It's very simple if you just use libraries for these steps. Lemmatization, however, is actually more useful in Turkish because you just actually remove certain parts from a word to get another version of the word instead of looking for another version of it. Let's say, for example, if you have like çiçekliye, it turns into çiçeklik. Like it just removes the e at the end and turns it into the original form instead of going all the way down to the root. It's more useful for Turkish, but I'm not sure about other languages. I don't think it's very good in English, and it's not a very important step again. So tokenization, this is the important part. Tokenization is when you get your data, you turn into sentences. You turn sentences into words. Then you turn those words into numbers in the next step in text representation. And it's really important, but it can be done in many ways. You don't have to do it in a specific way. For example, in BERT model, BERT uses its own tokenizer, which is really successful. I will explain why later if we have the time. I believe we are going to have the time. And so yeah, that's how you can make your text understandable for a computer, of course. That's what tokenization means. You're going to tokenize your data before you feed it into your model for training. And also, even when you want to use the model, the prediction is going to be done with tokenizer. So the model machine learning model can actually understand the input. So BERT, here we are finally. So BERT is a transformers model. What are transformers models? Well, transformers models are actually something very new. As I mentioned, like in 2020, they actually came into existence. And what they do is that not only do they actually turn the words into numerical values, they also, most of them have this thing called positional encoding, which they are going to keep this data. For example, you see the first word has the letters 0.34, 0.22, 0.08, 0.45. This is the first word. It comes at 4 letters. And we're going to see where is this word located at. If it's in the beginning of the sentence, it's going to have positional encoding 1. Second word is 2. The third word is 3. We can keep going until like the last word, for example, here is 10th. So why would that matter? The reason that this matters so much is, for example, in the English language, the order of English language is SVO. It's subject, verb, object. So it matters where the word is. If the word is in the beginning of the sentence, it can probably mean it's a subject. If it's in the middle of the sentence, it's probably a verb. If it's in the end of the sentence, then it's probably an object. That's why the location of the word in the sentence actually matters for the final result from the model. It's easier for the model to understand if you assign positional encoding to this. What makes BERT interesting here, however, is that BERT also has this thing called word piece tokenization. As you see here, for example, not only does it already knows what these words are because it has them in its vocabulary. Not only does it turn them into numbers here, like the number value of sentence beginning, which is a class, but it knows what ver means, it knows what he means, it knows what is means, it knows what sleep means. However, like in this case, our model doesn't know what sleeping means. So what it's going to do, the word piece tokenizer, is that it's going to keep it inside the separator, and it's going to say, okay, I know the word is sleep, so sleeping is probably related to the word asleep. So it's going to keep the ing at the end because it doesn't know the meaning. And it says if I ever learn what this means, I can come back to it. But if I don't know what this means, I can just assume that it's related to sleep. So this is actually really useful because your model doesn't just dismiss the word because it doesn't know it, because it doesn't know it in the vocabulary. It's actually going to assume the meaning based on the context, like a human does. And it really helps when it comes to accuracy of the model at the end. So you see, for example, what we have here is like various Himalayas in the word map. And in the second text, they spelled Himalayas actually in the wrong way. There is 2 S's at the end. And if you're using an older model like FastText from Facebook, which is a rather older model than BERT is in natural language processing for text classification, it's just going to dismiss the word Himalayas because it doesn't know what it means. But what BERT does is that it's going to keep the last misspelled letter and it's going to keep Himalayas separately, and it's going to assume what the meaning is. As you see, like the values here, the tokenized values at the end are numbers. So like the beginning of a sentence is 101 and the end is 102. This can change based on your language. We also normally use 2 and 3 as the beginning and end of sentence. And all of the words can have some numerical equivalent, as you see here. Let's move on. So what would we use BERT for? That's actually one of the best things about transformers models, and even more so for BERT, because they are not just made for one task. You can actually train BERT, let's say, on a certain language, then ask it for many tasks, not just one. For example, the FastText model I mentioned before that was developed by Facebook because they wanted a very quick model back in 2016, I believe. It's only used for text classification. But BERT can actually just be trained on a language, for example, Turkish, and then you can use it for sentiment analysis, emotion analysis. Like it reads the text, then it's going to assume what are the feelings of the person who wrote them. Like maybe you have seen in Grammarly, but it assumes how you feel about this text, how confident are you about the text, and like, you know, just the emotions that it shows like that. Yeah, that's also AI. It's assuming what are your emotions about the text. Also question answering, it can find answers for a question. It can generate text. If you like give it like certain keywords, it can generate text for you. There's also summarization. I'm actually going to show some of the examples right now. And also there's one really cool thing I mentioned. You can actually do grammatical correction. And it's really important. I'm just going to mention this since I believe we have the time. Yes, we do have time. I'm just going to mention this right now. If you are really interested in machine learning and natural language processing, to be specific, don't try to just immediately go for training a model. Natural language processing, especially when it comes to machine learning, is really important to understand the steps that you have to take. It's very important to understand it so that you can actually come up with solutions. Since like here we are not developing a new model, we're actually telling you how to use the model. It's important to understand how these models work so you can actually make use of them. For example, we had this problem in our workplace in which they wanted to take a text that is in a first person point of view, like a person is saying that my husband has like physically attacked me, I want to divorce him for this reason. And it would take the text and it would turn it into a report to speech so that it would be presentable in a court. I actually have a document on it in my Medium page if you want to learn about it more. So, but how would you solve this problem? Because there is no model that actually does this. There is no model that's been generating text like this. There is a similar model from OpenAI, but that's also not open source. If you want to do something like this, so I had to understand how certain models work, then I came up with the idea of using the model that is used for grammar correction. We would see first person point of view as a grammar error, then we would try to solve it by turning it into report to speech in Turkish. And this is why you should actually have a good understanding of how each task is done so that you can actually come up with solutions if you are really looking for a career in machine learning. Okay, let's actually move on to BERT examples. So BERT also does this thing, which is really cool. It's called masked language modeling. It's also being used by OpenAI. I think they actually first time used it for SpaceX, which is when you are trying to give a text to the machine, it's going to mask a part of it, 15% of it normally. For example, you see here the example that says the man went to the mask to buy a mask of milk. And the model is actually trying to fill in the blanks. It tries to guess what those masked words are. If it doesn't guess them correctly, it's going to remember this one, then go with the next sentence again. It's going to keep trying to guess until it can actually guess everything perfectly. The reason we would do this is that it actually enables us to do many things like next sentence prediction that you actually correctly have in Gmail, in English at least, not in Turkish as far as I know. So if you see in this GIF I put down there, I'm not sure how clear it is for you. As you see, the person that is typing this email has been using Gmail for a while, and the Gmail model can actually guess what he's trying to say next. When you try to text like Evan and like Malika, it guesses that he should say like first, hey Evan. Then at the same time it's going to suggest his address because he has been using his address a lot. It's going to keep guessing on the text that it has been given. So it really helps with next sentence prediction. You can also, of course, use this for grammar correction. When it tries to guess words, when it sees a guess, which like the words for the words in the inputs were wrong according to his guess, it's going to correct them. Even for actually spelling correction, or maybe even for pronunciation when it comes to speech recognition models. This is actually very useful. You want to say something? I hear someone's microphone open.
Yeah, but something like this model was created by linear regression, right? Not multilinear regression.
Yes, you can actually do it in many ways. You can actually do it with like very old methods like LSTM, maybe even RNN. You don't have to use modern tools, but the problem is with those is that you cannot keep teaching it most of the time. Even if you do, the model can actually get numb. What that means is like when you keep teaching it, it's going to stop learning at some point, and it's actually going to start getting dumber. That's why it's better to use models like transformers that are less likely to do that. And also, as I mentioned, transformers models can find connections like unsupervised that we're not going to be aware of how they do it, but it can just find some connections that's going to help us with things like this. Did you want to make any comments, by the way? Any questions I can answer?
No, thanks. Okay.
Yeah, no problem. But you are right. Yeah, you can do it in many ways. But machine learning has actually been improving really quickly. Every year we just have like new innovations, changing everything again and again. As I said, like the BERT model is actually being used like since 2021. It's very, very new. And there is this platform that I actually use to show you my models in. It's called Hugging Face. You can actually host your models there. Hugging Face has owns the transformers, and it's really cool if you want to learn about it. Just go to Hugging Face. You can just search for a model. People just upload their models for many different things. You can try all of them. It's mostly natural language processing, but it can host many things. Maybe you also know DALL-E. You probably know it. The model that you describe a picture and it draws the picture for you. It's also being hosted on Hugging Face.
But all of that is open source, right?
Yes, I mean, it depends on the person that is sharing them, but it's mostly open source. Yeah. So like DALL-E is actually, I believe, it's OpenAI. OpenAI is not always open source, unlike their name. So other things that you can do with BERT are name entity recognition. For example, here, this takes, again, it's in Turkish. I apologize. I couldn't find English versions as good as this one immediately. So you can actually, for example, say, whenever you see the name of a location, mark it as location. Whenever you see the name of a person, mark it as a person. See here, for example, Beam here in Turkey, it's a chain store. And Mersin Demirtaş is actually a location. And it's trying to give an address, so it recognizes the text as being location. And you can actually see the precision and recall, the F1 score for accuracy here. Also, if you're interested, we can talk about those later at the end of the meeting. And the models that people have developed on Hugging Face are very easy to use. You can see the code at the bottom. You can just grab them. Like in Python, you can just say from transformers, import auto tokenizer, auto model. It's going to recognize what model you need automatically. You can just import them from the website and start using them. It's very easy to use. You can also actually keep teaching them the models more if you want. That's the nice thing about BERT again, about transformers. And as you see, the model here was only trained on, actually it says 50, it's actually 5,000, sorry, I made a mistake here. The model was only trained on 5,000 tweets, and it's like 90% accurate on finding people's names. Another nice thing I want to mention, I forgot to mention this before, was like if you compare BERT and FastX, the previous generation model, was that FastX would actually, if you train FastX on 10,000 sentences, it would be equal to teaching BERT on 500 sentences. BERT was finding connections, much better than FastX was. However, there is a problem with BERT. There is some downside with transformers models, especially. The training phase, it's going to cost you a lot of time because it's happening in the background. You're not defining how it happens. It has to figure out ways to find similarities and things like that. So the training phase is going to cost you a lot of time. So this model that we used, BERTürk, it's like the BERT Turkish version. It's been trained on many Turkish texts that is on the Wikipedia though, and maybe around like 240 gigabytes of data. It understands Turkish language very well. That model we were using, it was trained on 4 RTX 2080 Ti's for 5 days to actually be usable like this. However, when you get past that training data, the model is going to perform very well. So it's actually about are you going to sacrifice your time for this? For big organizations, yes, it's actually very worth it. You have the resources, you have the time, then let's just use this model because you care about more accuracy. So another example of BERT here we have is actually translation. So this was made by Google for German to English translation. You can just find it on Hugging Face, and it's open source also. Yes, you can. Just import it very easily and start using the model. And you don't actually need any internet for this, of course. It's going to be running on your device real time. And it's working really well. It actually works better than Google Translate for the few things I tried. But again, training such models would take a lot of computing power. So that's the cost of using BERT. But as you see, it's working perfectly well. I don't know if any of you guys speaks German. I think this was a really good example. Then there is also summarization, as I mentioned. The model is going to be finding important information inside the text, first of all, which you can actually do by name entity recognition, like we did earlier, which was semi-supervised. Or you can just allow the model to just search around and find the connections itself to find the important data inside the text, then turn it into a much shorter text, paraphrase it a bit, and also turn it into a much shorter text. And to train such model, you would need really good data. So here they actually used data set is called MLSUM, which includes many different news organizations, and also it actually includes 5 different languages, I believe. You can also try it in English and French and many other languages. And it works really well in Turkish for things I've seen. Also in English, I tried shortening a page of CNN, and it just works really well. And you can just import these models, try messing with them a bit, try to understand how they work. If you have any problems, by the way, if you want to try these, you can use Google Colab, which is a really good tool. It gives you 10 gigabytes of GPU you can just play around with, and it can make it all easier. But again, I'm very sorry that the 10 gigabytes GPU is not going to be enough when it comes to doing heavy tasks with BERT, especially if you're having a lot of data. It's going to crash. So maybe you can do some limiting for Google Colab, but it's going to be very slow. So you might need to look for more powerful systems if you want to do language modeling. Maybe you can actually make use of the TPUs offered by Google, the tensor processing units. Yeah, probably, or actually rent them online if you're interested. But yeah, that should be about it for now. For BERT, I actually went really fast, I think. I hope you guys understood. If you have any questions, you can ask. Please go on.
So thank you, Nima. I saw some questions on the chat for from Mohammed, I think. Yeah, you can, if you can see the chat.
For quantum PC, I assume so. I've never even thought about it, but I think it should be easier for a quantum computer to actually process such things. But GPUs are actually better for using than most of the CPUs. Even if it's not image related, like natural language processing, it just works better on GPUs, and you can just turn your NVIDIA GPUs into TPUs in Google's operating system for GPUs, which is going to improve it a lot. Again, I don't think we can have access to quantum computers anytime soon, so don't count on it much. We have to wait for a while. But it may be revolutionary. It can actually revolutionize the industry. If you guys actually want to learn about how to use BERT, how we can use it, we can maybe have a meeting later in the upcoming weeks.
Maybe
if Ubay is actually up for it. Do you guys have any questions about the meeting? Okay, then I'm happy that you actually learned something today. I really hope so you actually learned something. You can actually just reach out to me on LinkedIn if you have any questions, or you can just reach out to Ubay to contact me. If I don't know any answers to something, I can just look around to help you with that. We should be able to get some answers from Google itself. I think Ubay can help you with that. Maybe you can try to contact some TensorFlow mentors. Don't worry about it. Just go out there and try it. Just try different things, try to play with these models, and that's how you can just learn. That's all I can say. Thank you again for participating. Thank you so much.
Thank you, Nima. Thank you. Thank you very much for the amazing event, and thank you for the amazing speech. It was very simple for the people who are still trying to learn AI for the first time, and it was very detailed enough for the people who know enough. It was a good mix. It was the perfect event for the first AI introductory event. Do you want to add any more things, by the way?
I don't think so. I'm just glad if it really helped people right now. If you have any questions,
find your LinkedIn and the website in the PDF, right? In the in the PDF of the
Send it in the
revision.
group. I'll send it in the group if it's okay with you.
Okay.
You can just search my name; it should show up. I have a very weird name. I'm gonna send it in the chat if you want to see it. Let me just send it here. If you just search my name, it should show up. Again, just contact me there.
All right,
Thank you
Okay.
again.
Thanks.
So I'm assuming because we have 10 more minutes on the call and it will shut down itself. But does anyone have any questions about the natural language processing in general, or even like a simpler question about machine learning? If anyone has something, it's your chance to ask an actual person who actually saw the industry and the AI itself. So I'm assuming everyone got the ideas very well today. Thank you.
Yeah, I think so. Okay, it was great to be here. I'm glad.
Thank you. Really honored to have you and to host you here in our GDC, our second event, and in our first in this new series. Thank you very much. And so thank you guys, and stay tuned for tomorrow's event as well about interning in the AWS, about how you can get an internship in a big tech company, and see you hopefully then. And thank you again, Nima. Have a good night, guys. Thank you. See you later.
Good night.